Andromeda Galaxy is the most distant object you can see from your naked eye, and also the brightest. If you are in the darker sky, away from light pollution, you can see this iconic object without any help from binoculars. But you don't see Andromeda Galaxy as it is, but what it was, 2.5 million years ago. There is a universal speed limit. Any information will only get transferred at a speed of light. The light coming from Andromeda Galaxy left it 2.5 million years ago. Let's say you are 20 years old and 20 light years away from Earth and took a look at Earth through a powerful telescope. You could theoretically view yourself being born. Little correction here, you wouldn't see yourself being born as it would require a really powerful telescope. But in principle, you could see our planet as it was at that time. Today, we have telescopes that are powerful enough to see 13.7 billion light years into the time, to the very beginning of the universe. We can look back at a time when there were no galaxies, stars, planets, asteroids, except hydrogen and a little bit of helium. Hydrogen and helium were produced within a few hundred seconds after the Big Bang. Big Bang only gave birth to the lightest elements. There were no carbon, oxygen, calcium, iron, or any other elements in the universe. But if you look human body, our body is made up of 65% oxygen, 18.5% carbon, 9.5% hydrogen, 3.2% nitrogen, 1.5% calcium, 1% phosphorus. So looking at the Big Bang, it doesn't create any elements except hydrogen, which would eventually create us. Then, where did we come from? It was the star. Elements found in us were created inside stars. The brightest things in the universe are also the ancestors of all of us. Stars are giant balls of hydrogen gas. First-generation stars were formed as lumps of hydrogen gas drew together and began to collapse under their own gravitational attraction. Stars are like nuclear reactors. They take hydrogen and convert it to something else. Inside the star, temperature and pressure are at a level difficult to even imagine. Under this extreme temperature, electrons get separated from nucleus, and two or more nuclei fuse to make heavier and heavier elements. You fuse 4 hydrogen nuclei and get helium. Helium is taken 3 at a time to make carbon. And add 1 more helium to the carbon, you make oxygen. And this continues until you reach iron. Iron is the end of the game. The life of the star is a constant struggle against the force of gravity. Gravity tries to collapse the star, where the star tries to stop gravity by releasing energy through fusions. And the balance between gravity pulling the star inwards and its energy pushing outwards is where a star lives. When a star finishes its hydrogen fuel, gravity starts to contract. So to stop that happening, it starts fusing helium and makes carbon in its core. And once helium goes out of stock, it starts fusing carbon. And the journey continues until it reaches iron. Up to this point, fusion gives energy to a star to hold gravity. However, fusing iron requires an input of energy rather than producing energy. When a star makes too much iron in its core, it loses its fight against gravity. The iron that makes our blood red is responsible for instant star death. Let's make a supernova. In just a matter of seconds, gravity will draw all the elements and shrink into tiny space, sparking the temperature in its core 100 billion degrees and more. Now it's like a nuclear time bomb ready to explode in the biggest cosmic explosion. A supernova releases almost unimaginable amounts of energy. Its flashes is so bright, it outshines the entire galaxy for several days or weeks. All of the elements heavier than iron are now to be created at this violent act. First-generation stars were massive. They were about 300 times bigger than our Sun. And the more the mass, the faster they will finish their hydrogen fuel and die in a supernova. When stars die, all the wonderful elements it has created are distributed into space. Also, the death of massive stars triggers the birth of new stars, and the process continues of death and birth. Heavier elements make a species of gases, minerals, asteroids, planets, moons, water, and eventually us. And it is not even just one star. There were a whole bunch of different stars that contributed to the elements found inside us. Remember, nothing in the universe is stable. Our Sun revolves around the Milky Way and takes 230 million years to make one transit. Till its birth, our Sun has circled the Milky Way 20 times. and we'll circle 20 more times until it will also run out of fuel and die out. Right now, you, our planet, moon, sun, and our entire solar system are traveling at an average speed of 230 kilometers per second. With this speed, we swiped up material from stars that died thousands of light years away. And due to the powerful supernovae, half of the materials in our galaxy have traveled by intergalactic winds. So it is not just one star. We have stuff in us as old as the universe itself. For thousands of years, we have been stargazers. These bright objects in the sky have always fascinated humans. But whenever we look up, the cosmos looks very far and unrelated. Even the closest star to our solar system, Proxima Centauri, is 4 light years away. But if we look deep, our relationship with the cosmos is very old. It looks like we created all the elements for us to exist physically. As Carl Sagan greatly says, the cosmos is within us. We are made of starry stuff. We are a way for the cosmos to know itself. So next time you stare at the cosmos, remember, you are the universe, being self-aware. Thanks for watching. Click here to subscribe.